Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to have a discussion on the topics that you really need to prepare on as far as paper 2 physics is concerned. We're going to first look at the instructions. Here you'll be provided with various instructions on what you're supposed to do in this paper. And I would like to remind you that paper 2 is 70 marks, and also you'll be provided with a formula sheet. Some of the formulas that I provided here are how to find frequency, power, orbital speed. We have also the equation of motion. Pressure formula is provided. Then also we have the formula for force change in momentum over time, which provided here. Don't forget that the formula for Doppler effect and motion in the universe is actually provided. So we are going to look at the first question that I've really decided to bring upon this paper. For instance, you need to really know how to answer a question to do with Big Bang Theory. Remember, Big Bang Theory is a question that comes from cosmology, and cosmology itself is a topic that tries to explain the motion of the universe. And the theory that is acceptable according to the specification that you are doing is actual Big Bang Theory. And Big Bang Theory comes at a point where it started by saying that the universe originated from a hot single dense point that expanded, and it claims that the universe is expanding up to this particular point. So we are supposed to explain how cosmic microwave background radiations support Big Bang Theory. I need to mention that there are different aspects that we can look at right now that can really ascertain that the universe might have originated from Big Bang Theory. For instance, the presence of microwave background radiation in the environment actually is an evidence that the universe might have been originated from Big Bang Theory. Also, the redshift that is emitted, displayed or shown from light emitted from distant galaxy, or the galaxy display redshift, meaning the light emitted from the distant galaxy actually in comparison with the light that you can have in the lab on Earth, it indicates a long wavelength, so meaning that's a redshift. So if all the galaxies in the universe are actually receding and moving away, and it will mean that they are displaying redshift. So the presence of CMBR, that is cosmic microwave background radiation, redshift that is displayed by distant galaxy, those are two evidences that support Big Bang Theory. But in this question, you are supposed to explain how CMBR supports Big Bang Theory. And we need to remember that cosmic microwave background radiation actually are observed to be everywhere on Earth, and they are spreading in all directions. So this indicates that the universe at one point might have been on one single point. So we can be able to say that cosmic microwave background radiations appear to be everywhere, and they are spreading in all directions. This implies that they might have been produced during Big Bang. And also we can also say that all points of the universe might have been in contact long time ago, and all that now the universe expanded from this single dense point. Another thing that you can also mention that the CMBR is actually over a long wavelength, so meaning that initially the universe might have been so hot, and now it has cooled down, and that is why now we have the long wavelength. So if you are given a question to explain how cosmic microwave background radiation support Big Bang Theory, you need to say that the CMBR radiations appear to be everywhere in all direction, and they are stretching in all direction. This implies that they might have been produced during Big Bang, and all points of the universe were in contact long time ago. The second evidence is that all the light emitted by different galaxies displays a redshift. And if they display a redshift, it means they are moving away from the Earth. But according to Big Bang theory, it claims that the universe expanded from a single dense point, and it's also expanding up to now. So which will mean that if we can be able to detect that the galaxy are moving away, it means that the universe is expanding, and that can also serve as the evidence for Big Bang theory. Another question that can arise here is determining the speed at which the galaxy is moving away, and you'll be provided with different measurements which can enable you to work that out. And you can be able to use actually this formula that we have there, which will mean that we can say change in wavelength is equals to reference wavelength equals to the speed of the galaxy over the speed of light. So V represent the speed of the galaxy, and then C is the speed of light, and then we have also the wavelength of light is lambda naught. So we can be able to identify we have 605 and also we have 683. So if we subtract this, we are going to obtain our change in wavelength divided by 605 equals to that. So if we make V the subject of formula in this case, we can be able to work out the speed of the galaxy. And in this case, we're going to work it out using your calculator. Can you just try to put it in to see what we are going to get? Okay, if we work it out, we're going to get the speed being equal to 3.87 times 10 raised to power 7 meter per second, which can be approximately 3.9 times 10 raised to power 7 meter per second. That is the speed at which the galaxy is moving away. And something I need to mention is that those galaxies which are very far, they actually displays a large redshift, and also they move away at a very, very high speed. So closer galaxies, they move at a little bit lower speed away from the universe, and those that are far, much farther, they move at a higher speed. And if you are new to Proflan YouTube channel, consider subscribing so that in time we are going to upload further tutorials, you'll be notified. Let's look in the next question here. This is a question to do with momentum, and we are going to have an explanation of how to work out momentum. Momentum equals to mass times velocity, of course. And in this case, you are supposed to state the correct units for momentum. And if you notice that the unit for mass is actually kilogram and velocity meter per second. So if you multiply this, we can be able to see that momentum is kilogram meter per second. So which will mean that if we are going to select our answer is going to be C. Next, you need to know how to work out question to do with collision, bodies which are colliding, and also explosions. And in this case here, we have an explosion, meaning that particles are actually separating. So if P and Q are separating and they are moving in opposite direction, we are going to say that the initial momentum is actually 0. But the first question here we are being asked is to state and the examiner to check whether we understand the concept of principle of momentum. And remember, according to the principle of momentum, momentum before collision, total momentum before collision, total momentum before collision equals to total momentum after collision, then provided there is no external force. In this question, we are going to say that total momentum before collision is equal to total momentum after collision, and that is provided there is no external force that is acting. We're supposed to calculate the magnitude of the velocity of the particle P after the explosion. What we need to appreciate is that before collision, total momentum before collision was actually 0, and then we're going to say V times 2.9, that is will be the momentum of P, and the other one will be negative 3.7. I've indicated negative because it's going to is moving in the opposite direction, and the other one was moving to the left. Q is moving to the right, So we are going to, because we are talking about velocity, it means we're going to assign one negative because of the direction. Velocity is a vector quantity. Momentum is also a vector quantity. So if we multiply that and then we try to make V the subject and solve for V, this is exactly what we are going to get. If we divide these two, we are going to get our velocity being equivalent to 2.4 meter per second, and then we transfer this here so that we can be able to make the examiner happy in that case. All right, so we can now move to the second part, and part C rather. A child drops an egg from a height of 10 centimeters and the egg lands on the floor. Explain why the egg is likely to break if the floor the egg is likely to break if the floor is covered with a thick carpet than if the floor. Explain why the egg is less likely to break if the floor is covered with a thick carpet than if the floor was were covered in hard tiles. Remember, when we have a thick carpet, it means that the carpet is going to increase the time of impact. And if time of impact is increased, it is going to reduce the rate of change of momentum, which means that the overall force experienced by the egg is going to be less. So we're going to say the carpet increases the time of impact, and this reduces the rate of change of momentum. And eventually, from the formula, remember the formula, force equals to change of momentum over time, then we can be able to say that the force is going to be reduced. From this formula, we can see now if time is increased, then the force is going to be less. So we can now therefore say that the carpet reduces the force of impact, and this reduces the chances of the egg being broken. So this formula also, you really need to know how to use it, because in any given point, if a question is asked from here, you'll be in a position to answer as well. Moving to the next area that you really need to learn on and prepare on so well is the concept of magnetism and electromagnetism. And here we have a question about electromagnetism. Remember, a magnet is a material that attracts a magnet or repel a magnet or attract magnetic materials. Then we can be able to generate magnets from magnetic materials through the flow of current, and electromagnets are magnets or type of magnets which are generated due to the flow of current. But now in this case, we are told that the diagram shows a magnetic field around a straight section of a copper wire. Explain why the copper wire has a magnetic field in the diagram shown. So when there is current flowing through a wire, then around that wire, we are going to have magnetic fields created around it. We're supposed to explain why. We are going to say that possibly there is a current flowing along the copper wire, and this current will be flowing to the right because you can see the direction of the magnetic field. Then we can be able to use Fleming's grip rule, rather we can be able to use right hand grip rule in order to determine the direction of the field. So we can say in that case that the field exists around the current, the field exists along the wire or around the wire because there is a flow of current inside that. So something else that you really need to remember on that regard is the concept to do with how is the magnetic fields, the strength of the fields affected. If you increase the amount of current in this copper wire, you are going to have stronger fields around it. So the strength of an electromagnet can be increased by increasing the amount of current flowing through the coil, and also by increasing the number of turns in an electromagnet. So in this case, we're going to say there is fields around the conductor, because there could be current flowing through the wire and it's moving in the to the right. A student investigates how the strength of an electromagnet varies with the current. Then you can see now, this is the concept that we're talking about. If there is more current flowing through the coil, then the electromagnet will be stronger, so meaning to be able to attract maybe more materials. All right, so we are given an ammeter. An ammeter can be able to measure the amount of current. A variable resistor can be able to vary the amount of resistance to allow a given amount of current to pass through. We have an electromagnet which is formed from a soft iron core which is easily magnetized and demagnetized. So in the event they ask you which is the best metal to be used for the electromagnet, you say is a soft iron core. But a best metal used to make a permanent magnet is a steel. Is steel because it's a hard magnetic material, because once magnetized it retains its magnetism for a long period of time. All right. Also, we have mentioned that to increase the strength of this electromagnet, you need to have more coils. You need to have also more current added in. How to destroy an electromagnet? You use alternating current, but how to uh, create an electromagnet? You use direct current. This method, this is the student's method. Switch on the electromagnet at its maximum current. Place a load of 100 grams so that it's held above the floor by the electromagnet. Slowly reduce the current in the electromagnet until the load falls from the electromagnet. Record the current at which the load falls. Record the current at which the same load falls 2 more times. Yeah, so let's see. Record the current at which the load falls. Record the current at which the same load falls 2 more times. Repeat the method for the load of different masses. Suggest the suitable safety precaution for the student's investigation. And since there is some masses falling down, the student needs to ensure that his foot is away from the electromagnet so that those masses don't fall and end up injuring the student. And also the student needs to take care of the heating effect of electric current. So should switch on and off the switch when not in use. All right, so we can be able to note that down here. Ensuring that the student should take care of the heating effect of the heating effect of electric current. We are supposed to calculate the mean current when the mass of the load was 600 grams, and then we can be able to say we shall add 1.79 plus 1.84 plus 1.87 divided by 3, which is going to translate to actually 1.83. 1.83. Then we can be able to write it here. We're supposed to plot a graph of mean current against mass of the load. So in the you're gonna have a graph to draw in that exam. So which means that you really need to understand the scale, what should be on the y-axis and what should be on the x-axis in this case. So part of it was drawn for us in this case. We are good to go. Yeah, we need to identify that the mean current, mean current is going to go in this other side, and then we shall write the mean current in amperes, so that I can now move it this end. We can now start plotting. We have 100 gram to 0.30. We can see it's here. 200 grams is 0.58. We go back here, it's around here, move to 200 somewhere. Let's move up a little bit. Let's move right. Okay, that's the point. Then we need also to go for 300. It will be there. 400, 400 is 1.23. So let us look for it. 1.23 will be probably there. 500, it comes at this particular point. Then finally we have 1.83, which will come at this point here. Now we can join and have a line of best fit. We are drawing the line of best fit. A line where most of the points are going to pass is what we call the line of best fit. All right, okay. So we can just now move to the next part. So basically you need to be in a position of drawing graphs, and the most important thing you need to know when drawing graphs is to choose a scale that can be able to accommodate all the values, all the data that is in the table that is provided. A student predicts that the load of 1.0 kg falls when the current is 3.0. Remember, we had collected, the data was collected and the graph was drawn, but 1.0 kilogram, which is equivalent to 1,000 grams, is not in the part of the graph. But from that, the student maybe might have predicted from the graph 500 grams is 1.5, then probably times 2 will tell us that 1,000 grams is equals to 3 amperes. That could be the student's assumption. But what we know is that from the graph, that is from the assumption, that is the case, and that was supported from the graph. But that could not be true, because in the event you are trying to give an assumptions, and yet those values you are using, or those assumptions that you are drawing, are out of the range of the data that was corrected, it may not work. It may not work because the experiment may not be consistent with those values that you are trying to conclude with. Yeah. So the range of the graph, the 1.0 kg is actually out of the range of the graph, and the pattern may not continue the way the data was before. So that's actually the comment we can be able to give about according to the students. So basically, also something that you need to remember in the coming exam, you may be given questions to justify whether the student's conclusion is true, especially from graphs. Yeah, whereby you are given data, a graph is drawn, and then you are told that the student decide that the relation that connects this quantity and that quantity is this formula. Try to check if the student's conclusion is correct. So that means in that kind of scenario, you need to use the data from the graph and then try to put in and check if the values agree or not. Now, the next area that you really need to understand is the how transformer works and calculations involved in transformers. So in this case, you need to understand also different types of transformers, that is a step up transformer and a step down transformer, and the use of each of them. Give the name of a suitable method that can be used to in the core of a transformer, and that is actually a soft iron core, because it can easily be magnetized and demagnetized. And the purpose of a soft iron core is to link the magnetic fields to the secondary coil in that case. State the formula linking the input power and the output power of a transformer. At 100% efficient, we are going to say that the power input equals to power output, and that is exactly what is expected here. So supposedly this one of a question that you can be asked, and you need also to know how to use that formula in terms of calculations. Now you can see here we are given input voltage is 275 kilovolts, and output voltage is 230 volts. So meaning this is a step down transformer. It's reducing voltage. And when also you can even look at the number of turns in the primary coil and the secondary coil. The secondary coil is in the output, and the primary coil is the input. So if you have more turns in the input, it means that is than the output, then that means that is a step down transformer, and the purpose of a step down transformer is to reduce the voltage for safety and domestic use. All right, let's see the next question. A step down transformer has input voltage of 275 kilovolts and output voltage of 230 volts. The transformer has an output current of 95 amperes. We're supposed to calculate the input current to the transformer, assuming the transformer is 100% efficient. So that means there's no power loss. Power in equals to power out, the way we had stated. So we can be able to say power in equals to power out. And remember now, to work out power in is voltage in the primary coil times current in the primary coil, which is the same as voltage in the secondary coil times voltage in the secondary coil times current in the secondary coil. So we can be able to substitute all that we have into this, because we know the voltage here was 275 kilovolts. But you need to remember that kilovolts, K means 1000 in physics, so that you can be able to get the question right. So we don't know the current, and that's what we're finding. But the voltage in the other case was 230 and the current is 95. We can divide both sides by what we have on the left, and then our current is going to translate to 0.0, right? Let's 0.079 amperes as the current in the primary coil. We are supposed to explain how transformers are useful in large-scale transmission of electricity. You may draw a diagram to help your answer. Yes, in the power station, when power electricity is generated, then we have a transformer which is known as a step-up transformer. This step-up transformer increases the voltage so that it can be transmitted at high voltage and low current to avoid power loss in the process of transmission. So we can be able now to say that once power is generated at the power station, we have step-up transformers, and the purpose of the step-up transformer is used to increase the voltage so that electricity can be transmitted at high voltage but at low current. And in that case, when that is the case, there is no going to be power loss in the process of transmission. So when this electricity reaches nearby the homes where the people need to use it, or different industries, we have what we call, in our neighborhood, we have transformers which we call step down transformers, which are going to reduce the voltage now to a manageable level, whereby we can be able to use them in our devices and to avoid maybe electric shocks and overloading. So we are going to say step down transformers is used to reduce the voltage or to decrease the voltage so that it can be able to be used in our homes and also for safety purposes. All right, let me actually save this so that I can be able to upload it to you so that you can download it and go through it as you're approaching your exam. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload a tutorial, you'll be notified. And consider also sharing this particular video to your friends. Recommend it so that they can also benefit from the same. Let us encourage each other to come on board and help the channel to reach 500 subscribers at least. As you can see right now, we are at 493. So I hope by the end of this video you will be at 500. So like, share, comment if the video was helpful, and once you have done your exam, come back, tell us at least if you really benefited from the same. Another way the question can be asked in transformers, we are supposed maybe to explain the operation of a step down transformer or a step up transformer. Now in this case, you need to be very, very categorical that when alternating current, remember, for a transformer to work, there must be alternating current, that is AC current. because AC current keeps on changing size and direction, so it's going to create magnetic fields which constantly change size and direction. So which will mean that the created magnetic fields are going to cut across the secondary coil, and that will result to inducing a voltage in the secondary coil, which result to the flow of current. So a transformer cannot work with direct current because direct current produces magnetic fields which are constant. So for a transformer to work, you must have alternating current, which will create magnetic fields which are constantly changing size and direction, and those fields cut across the secondary coil, resulting to induction, inducing a voltage in the secondary coil through electromagnetic induction. And if you are asked how you can be able to increase the amount of voltage induced in the secondary coil, you can say you need to increase the amount of turns in the secondary coil or increase the amount of voltage in the primary coil. Yeah. So we are supposed to explain this question, the operation of a step-down transformer. You need to understand first that a step-down transformer is a type of transformer which has less secondary coils or less turns in the secondary coil than in the primary coil. And what is it used for? A step-down transformer is used to reduce voltage. So, meaning that if you are having less coils in the less turns in the secondary coil, it means less voltage is going to be induced. Now, let's dive in so that we can be able to write one of the classical explanation you can give in your exam as a step-down transformer. First, we're going to say step-down transformer is a type of transformer that has more coils, more coils in the primary, more coils in the primary, more turns the primary coil than the secondary coil. But what is it used for? It's used to reduce or decrease voltage. So we can see when alternating current flows through a primary coil, it creates magnetic fields which are constantly changing size and direction. So when these created magnetic fields cut across the secondary coil, a voltage is induced in the secondary coil. And since we have less turns in the secondary coil, we are going to say less voltage is going to be induced. Less voltage is going to be induced in the secondary coil, thus reducing the voltage. So basically, that's what you are supposed to say or write in your exam in order to earn the 4 marks. So let's check the key point that you need to include. You are supposed to include in this case. Yeah, let's see the key points that you are supposed to include. Yeah, the first key point, because you are talking about step down transformer, you must indicate that it reduces voltage. We'll talk of magnetic fields which are constantly changing direction and size. We shall talk of the magnetic fields created cutting across the secondary coil, and then we shall talk about induced voltage which result to the flow of current. So those are the key points that must be included for you to earn all the 4 marks in that case. State the formula linking input voltage, output voltage, and the number of turn ratio and the turn ratio of a transformer. So we can be able to say number of turns in the primary coil over number of turns in the secondary coil equals to voltage in the primary coil over voltage in the secondary coil. So which will mean that at that given point we shall have a question whereby you are supposed to do the calculation. You see, in the primary coil we have 160 turns and the voltage is 12 volts. In the secondary coil we have 45 turns, and then we are supposed to calculate the voltage in the secondary coil. So let us just first substitute what we were given there so that we can be able to work it out. And if you work it out, you can see 45 divided by 16 times 12, that is going to give us 3.4 volts as the induced voltage in the secondary coil. Another question that you need, or topic you need to look at, is the topic on evolution of stars. And in that case, we need to talk about Hertzsprung-Russell diagrams. You need to understand different regions of an HR diagram. You need to know where the main sequence is, and you can see the middle part that we have here is actually the main sequence. Then down here we have the white dwarfs, which is actually almost the end of life cycle of a star. And then the upper part, we are going to also say we have the red giants. Here we have the red giants, and in other case, if you are asked, at the top here we have the red super giants. So you really need to know how and where all these regions of HR-Russell diagrams really are. Now, state what's meant by the term absolute magnitude, and we can say this is the measure of how bright stars will appear if they were at a standard distance from the Earth. So you need to understand the difference between absolute magnitude and also apparent magnitude, which are the terms that are used in astronomy to describe brightness of stars. But for apparent brightness is a description of how bright stars appear from the Earth. So in this case, we are going to look at that in the next area, right? So remember, the standard distance from absolute magnitude is actually 10 parsec, or 32 light years. And the 1 light year is a distance light travel in 1 year. So that one also you really need to remember, because that is an astronomical unit of measuring distance in astrophysics. All right, in question B, we are told the sun emits various parts of the electromagnetic spectrum. So which part of the electromagnetic spectrum causes damage of the human surface skin cells? Well, this is actually ultraviolet. This is UV. And then we are asked which of these increases the risks of damage of the human surface skin cells. We can say this is actually sunbathing. All right. So having understood different aspects of the electromagnetic spectrum, you need to know the characteristics of common properties of the waves in the electromagnetic spectrum, the wave equation, how to use it, and also uses and dangers of different waves in the electromagnetic spectrum. Don't forget to look at also moment of force. Remember, you may be asked to state the principle of moment. Clock at equilibrium, which state, remember to also review on how to state the principle of moment. Remember, principle of moment states that at equilibrium, clockwise moment equals to anti-clockwise moment about the same point. You need also to understand what are the factors that can affect a moment of force. Remember, moment is calculated from the force times perpendicular distance. So which means that if distance or force is actually varied or changed, it will mean that is going to affect the moment of force. And remember, force moment is the turning effect of a force in this case. So here we're having two pivots. So this is a question that mostly is of recent papers that has been consistently tested, because most students really find a challenge when they are explaining question to do with moments and they are having two supports like that. And I'm going to demystify that, taking you through what you're supposed to do. In this case, what you need to know is that when you are calculating maybe the force at F, you are going to take A as the pivot. So all the distances will be measured from where the pivot A is. The diagram shows a wooden plank balanced horizontally on two supports, A and B. A block is suspended from the plank between the support by a cable of negligible weight, meaning that the cable has very little weight, which can be neglected or cannot be considered in this case. Now, the weight of a block is 260 Newton. We're supposed to state the formula for the formula linking moment, force, and perpendicular distance from the pivot. and that case we are going to say that moment equals to force times perpendicular distance from the pivot. And by taking the moments about point A, calculate the force F. So in this case, we are going to apply this formula, yes, but if you don't know that distance are measured from the pivot, you are likely to really slide and get yourself at the wrong point in this particular question. So in the event you are given a question like this, look at where the force is. Now for instance, the pivot is at this point A, and for us to work out this question, we are going to consider that the block is going to give us a clockwise moment, and this force is going to make this plank to move upward, so that is anti-clockwise moment. So the distance for clockwise moment is going to be 225 meters, this particular distance, but the distance for anti-clockwise moment is going to be from A east to where the force F is, which is actually 80 centimeters. So meaning that we can be able to say now clockwise moment using the principle of moment, clockwise moment equals to anti-clockwise moment. In that case, our clockwise moment is going to be, since the two distances are in centimeters, we can just work with them the way they are, and then we can say the force is 260 newtons times 25 should be equal to the force F times 80. Then we can divide by 80 and by 80, and we can see that force F is going to translate to, let's try to put that in our calculator, which is going to be 1.25 Newton. So that is actually the force that is going to be at point B. So let me just try and move this down so that we can be able to have it where it's supposed to be written. Yeah, so that we can have it here. And then I'll be able to transfer that answer at this given point just to make the examiner happy. Just to make the examiner happy. We're supposed to explain what happens to the magnitude of force F. What will happen to the magnitude of force F if the block is moved towards support B. So you see, we are trying to say that the force is going to increase, and the reason as why the force is going to increase is because the clockwise moment will increase. Yeah, the clockwise moment will be increased, because if the block is moved towards B, it means the distance from the pivot A to where the block is will be larger. Yeah, that's what I'm trying to say. We have it here now, but if we move it that way, we're going to have a larger distance from A. So meaning the clockwise moment is going to be larger, then it means the force F must increase to balance with the clockwise moment. The distance from the pivot increases, so the clockwise moment, and the clockwise moment increases. So this implies that the anti-clockwise moment must increase to keep the system balance. So the force must also increase. Weight acts in that direction, and remember, when you are drawing that, it should be from the center acting downward. The block has also experiences a force due to the tension in the cable. Explain why the block remains stationary when it's supported by the tension force. Remember, objects, when objects are balanced, when the forces is balanced, then that object is not going to move because there is no resultant force. So we can say, therefore, it will be that the reason as why that is happening is because the weight and that is acting downwards and tension that is acting upwards are equal in magnitude. So the resultant force in that case is actually going to be 0. So the object is going to remain stationary. When there is no resultant force, the object will remain in its state of motion or in its state of rest. Explain why the force acting on the block are not an example of Newton's third law of motion. Remember, Newton's third law of motion states that for every action force, there is equal and opposite reaction. So we are going to state that the forces acting on the forces are acting on the same body and they are not of the same type. Remember also to look at energy resources, and under energy resources we can talk about renewable energy resources and non-renewable energy resources. Remember, renewable energy resources are those energy resources that cannot be depleted, that can never be used up. But non-renewable, once used, it's very difficult, or they take a very long period of time to be replaced. You need to understand also advantages and disadvantages of different energy resources, review on those areas, review advantages of solar, wind, hydropower, geothermal, and so that you have a wider spectrum on how you are going to answer different questions. We have also nuclear energy power, which is a question that I've tried to bring on board to review on that. So which means that if you are told, for instance here, we are told that uh, give the product of nuclear fusion. What are the product, the end product? Because the product released during nuclear fusion have high energy in their kinetic energy. So now, which are the products? Of course, we are going to talk about daughter nuclei being produced, and also we have neutrons also produced at the end product. So some of the disadvantages of nuclear fission is that we have nuclear energy waste, radioactive waste, and also this kind of energy resource is also non-renewable. It can be used up. We have a question to do with power. Remember, power can be defined as the rate of doing work, but we can also talk about power as the rate at which energy is transferred. So in that case, power is the rate at which energy is transferred. Can be able to use the formula for power in order to work out the minimum taken to transfer this amount of energy, and then we can be able to make T the subject in this case, which is going to be of 7.49 times 10 raised to power 9. So if we work it out, we're going to get what? It's going to be equivalent. Let us work it out using our calculator. And we are going to give our answer in seconds in this case. A student uses this method to investigate the speed of sound in air. Set up an oscilloscope to detect and display a sound wave. Use a computer and a loudspeaker to produce a sound of known wavelength. Use the oscilloscope to determine the frequency of the sound wave. Use the formula to calculate the speed of sound. We are supposed to give the name of an additional equipment that is required in this case, and actually that is an instrument that can be able to pick sound, which is a microphone. The diagram shows the oscilloscope screen. We have the direction, the y direction. One square is 5 millivolts. That's actually the amplitude. And we have the x direction, which we have here, which is our time base. So meaning that we can determine the frequency of the sound wave by going to the time base. We can see 1 square represents 0.5 milliseconds, and the 1 millisecond is actually in order to convert this 0.5 millisecond to seconds, we need to divide that by 1,000. So if we are working out the frequency, we need to know period. What is the period? A period is a time for a time taken for a wave to make one complete cycle or oscillation, and that is actually going to be from there to that point. So the period here we can see is actually equivalent to about 1.6 squares. So times 0.5, and then I'm going to say this is going to be equivalent to how many milliseconds? It's going to be 0.8 milliseconds, but I need to convert that to seconds by dividing by 1,000, so that we have our time in seconds. Now remember that frequency is equals to 1 over periodic time, or 1 period time. So if we work it out, we're going to get 1250 hertz as the frequency. If you are given, maybe for instance, what 1250 hertz, and you're asking what does that mean, that means this wave makes 1250 cycles, complete cycles, all oscillation every 1 second. So you need to understand also what that means, because I've seen questions like that in previous years. The wavelength of sound wave is 27 centimeters. We're supposed to calculate the speed of the sound wave. We are going to use the wave equation, and in this case we need to make use of the wavelength, and actual wavelength here is in centimeters, so we have to divide by 1000 so that we have it in meters before multiplying. So that becomes 337.5 meter per second, which is approximately 340 meters per second, which is actually the speed of sound in air. We are supposed to describe how the oscilloscope can be adjusted to show fewer cycles on the screen, and this can be done by decreasing the time base. By decreasing the time base, we are going to have fewer cycles on the screen. In question number 10, we are looking at question to do with specific heat capacity. So this is one of the area also that you really need to know you for you to sit for that exam comfortably. Definitely there will be a question on specific heat capacity calculations, defining specific capacity, so you need really to be well anchored on how to answer those questions. We are told to state what's meant by the term specific capacity. Specific capacity is the amount of thermal energy required or absorbed, this amount of thermal energy required to increase the temperature of a substance by 1 degree Celsius. So if you are asked what's meant by the specific heat capacity, you're going to say that's the amount of thermal energy required to change or to increase the temperature of 1 kg of a substance by 1 degree Celsius, or by 1 Kelvin. So right, so we can write that and then move to the next question, whereby that we are supposed to use the information in order to work out the specific capacity. And also you need to prepare on how to explain or describe how to describe an experiment to determine specific heat capacity. But this particular question down here is based on the data provided, and then you are supposed to use the data to show that the specific capacity of this acid is approximately 6 joules per grams per degree Celsius. So units for specific capacity also you ought to know that. Now we are told that the mass of the acid is 58 grams. When the boiling tube is placed in water, the temperature of the acetic acid increases from 21 to 37. So meaning from 21 to 37, we can be able to calculate the change in temperature, the temperature change. Then we are told that the acid does not melt. So it means that this temperature here is used to increase or raise the temperature of the acid at its solid state. Now, the temperature of the acetic acid increases. An additional, for this to increase to that extent, or to increase from 21 to 37, additional energy of 3500 joules were required. Yeah. So we can be able to now say quantity of heat or change in thermal energy is going to be the mass times the specific capacity times the change in temperature. So this is the formula we're going to use. Then we are going to identify that the energy is 3500 equals the mass, which is 58. Because specific capacity was given in joules per gram, it means we are going to use the mass in joules per gram. But if specific capacity was given in joules per kilogram, you have to change the mass to be in kilogram as well. Then we can subtract 37 and 21 in order to get the temperature change. We need now to substitute in and make C the subject of the formula. Working it out, we are going to get our answer being 3.77 joules per grams per degree Celsius, which is actually approximately 4 joules per gram per degree Celsius. The true value of the specific capacity of the solid, as said, is 2.3. So why is it that it's 4? So we can give a reason, and we can say that this because some of the energy was absorbed by the glass test tube, or some energy was lost to the surrounding. That's why our experiment is not accurate. So more energy was absorbed to raise the temperature of the surrounding, and maybe the temperature of the test tube. So that's the error in the experiment. You need to learn about cosmology. Make sure you go through cosmology, theory of remember the theory of the origin of the universe. We talked of the Big Bang theory, evidence for Big Bang theory. Yeah. So describe how the size and temperature of the universe have changed since Big Bang theory. The size has increased because Big Bang theory claims that the universe expanded from a single dense point, which means that as it claims that the universe expanded, yes, and is still expanding. So the size of the universe has expanded, has increased, as well as the temperature has reduced. It has cooled down. The size of the universe has expanded, and the universe is expanding, and it's also cooling down. Yeah, it's also cooling down. Discuss two pieces of evidence that support Big Bang theory. We say the first one is the presence of cosmic microwave background radiations that are everywhere and stretching in all directions, which could have been produced during Big Bang. Yeah. And the second one, we say that is the redshift that is displayed from distant galaxies. So the second evidence is the redshift that is displayed from distant galaxies, which indicates that the universe is expanding as claimed by Big Bang theory. So as you are going to do this exam on Friday, make sure that you have a good understanding on describing this evidence of Big Bang, Big Bang theory, Big Bang theory, Big Bang theory. Right. So we need to change the gear and also move to something else. Still, we can look at Hensprung-Russell diagram. Maybe a question can be asked differently. That's why you see I'm just bringing up different questions on the same concept. Then we said here is the red giant. We have here the white dwarfs, and then this one we say this is the main sequence. All right. Then we have the red supergiant at that particular point. Yeah. So we need also to remember. I need to mention this. Remember the evolution of a star. How is a star formed? Yeah, formation of a star, the life cycle of a star. We have massive stars and those stars which have similar mass as the sun. Don't forget to go through that. And if you have a problem on answering such kind of questions, I'm going to add a link in this down. Check in the description of this video. You are going to have the links to some of the explanations I've given regarding this concept, so that by the time you're going to sit for that exam, you are in a position to answer them. Now, the boxes give 4 points, A, B, C, and D, on the 4-star classification, we're supposed to draw lines connecting each point to the correct star classification. For A is actually a bright star, and this is a star which is brighter than that of the sun. You see, because it's at the higher point. Yeah, so that is going to be a very bright blue star. And then we have B. B is going to be what? B is what? B is a red giant. C, where is C? C is the main sequence here. It is actually a star similar to the sun. Yeah. Then we have a white dwarf at D. Yeah. Describe what's meant by apparent brightness, and we're going to say this is how bright stars will appear. How a star appear from the Earth. But the other one, remember, we had talked about absolute magnitude of a star. So you need to understand the two differences so that anytime a question is asked from here, you are in a position to answer. Also, Doppler effect that is displayed in stars. We are told that this question is about redshift, and the diagram shows two identical stars A and B orbiting each other like that, and then they are moving in that direction. Light from each star arrives at the Earth. As the star moves in their orbit, the wavelength of the light observed at Earth changes due to the Doppler effect. Remember, what's Doppler effect? Doppler effect is the change in frequency or the change in wavelength due of a wave due to relative motion between the source and the observer. Now, for instance, remember, if maybe you are maybe in KFC and an ambulance is passing near KFC and you are enjoying your meal, you can be able to tell whether the ambulance, due to the sound produced, whether it's approaching or it's moving past you. And the change in the pitch and the change of the frequency and the change of the sound you hear is due to Doppler effect. So in the event you are being told that define Doppler effect, Doppler effect is the change in frequency or a wave or wavelength of a wave due to relative motion between the source and the observer. So if the source, maybe if the ambulance is coming towards you, will hear sound of high pitch. So that is high frequency. If it's moving away, you'll hear a strange voice and all sound, which means that frequency decreases and you hear sound of a low pitch. This happens also to the motion of stars. When stars are moving away from the Earth, the light we receive has a longer wavelength and a low frequency, so meaning that is a red shift. So when there is a red shift in astronomy, astronomers can be able to say that celestial object is moving away from the Earth. So because all the stars display redshift, it means the universe is expanding. All right, let's now go back to the question. Add an X to the diagram to show the position of the star B when the light emitted from it shows maximum redshift. It will show maximum redshift at this particular point when it's moving away. Yeah, because this is the point here. Let me just draw at this particular point. Let me just move it. Yes, this is where the object will show maximum redshift as it's moving away, right? Light is received from a distant galaxy. In order to work out the speed of the galaxy, actually, we're going to use this formula, and then we shall substitute. Yeah, so we have worked most of these questions. So I believe when you are going to do it on Friday, you remember this tutorial, and then you will come back and tell us, did this question appear? And let me just give you a tip. I have a question, however much this question, however different this question can be asked, the wavelength that you put below should be the smaller wavelength. For instance, 550 is smaller. That's the one that you put as lambda naught. Lambda naught is going to be the smaller wavelength that we have, and actually that's the reference wavelength that we have, maybe the source in the lab on Earth all the wavelength of light. Yeah, so when we substitute that, we can see it's actually 6 million, which is actually 6 times 10 to the power 6 meters per second. State what's meant by the astronomical term a galaxy. So you need also to understand some of these terms. This is a large collection of billion of stars, and this is a large collection of billion of galaxies. Which one is that? That's a universe. And then if a question is asked that way on Doppler effect, still also you are going to answer it. But now if you are given different wavelengths like that, and you are told to compare and comment on the motion of the galaxy, those that display a wavelength which is more than the laboratory sample, it indicates a redshift, meaning the galaxy is moving away. Those that have less wavelength than that of the laboratory, like for instance galaxy A, it means this star is approaching the Earth, is coming towards the Earth. So in order to compare that, we're going to say that galaxy A has a lesser wavelength than that of the laboratory sample, so it's moving towards the Earth, so it's displaying a blue shift, and this one is displaying a red shift. So a red shift means it's moving away, moving away from the Earth, moving away. And since that's actually wavelength is larger, it means it's moving away at a faster rate. So it's also distant. If it's distant, it moves away at a higher speed. Use the data from the table to work out the speed of that galaxy B. So we can be able to use that and this one in order to work that out. And if you have gotten value from this particular video, consider subscribing so that anytime we're going to upload further tutorials, you'll be notified. You'll be notified. Remember, as you are joining A levels, we shall work together and we shall be uploading more tutorials on matters physics and math. So I really wish you the best of luck in your exam on Friday. Please consider subscribing and share this channel to your classmates. See you in the next video.